Greetings students. In this lecture, we will discuss some of the other important functions. Starting off with the explicit function. If y is easily expressed in terms of the independent variable x, then y is called an explicit function. Symbolically written as y is equal to f of x. For example, we have y is equal to under root 2x plus 1. Now we can see that y can easily be expressed in terms of x, hence it is an example of the explicit function. Similarly, y is equal to 4x square and y is equal to 3x plus 6 are all examples of the explicit function. Now, contrary to the explicit function, we have implicit function. If y cannot be expressed in terms of x, then y is called an implicit function. For example, if we have x y square plus 2 x square y is equal to 0. Now in this example, we can see x and y are very jumbled up and they can't be expressed easily in terms of x and y. Hence, this is an example of the implicit function. Moving on, we have even function. A function is known as even function if f of minus x is equal to f of x. Which means that if we replace x by minus x in the function and we get the same answer, then the function is known as the even function. For example, if we take cosine x, we know that cosine eats the minus sign, so if we replace x by minus x in the cosine function, we will still get cos function as it is. Hence, it is an example of the even function. Now moving on, we have odd functions. For odd functions, we have f of minus x is equal to minus f of x. That is, by replacing x by minus x, we would have a minus coming out of the function. Now, in order to understand it, consider the example of the sine function. We know that in the sine function, if we have sine of minus x, we would be left with minus sine of x as minus comes out of the sine function. After replacing x by minus x, of course. Hence, it is an example of the odd function. Now, absolute value function. You can consider the absolute value function as the function that always remains positive. Negativity is not possible when it comes to the absolute value functions. Absolute value functions can be represented as x if x is greater than or equal to 0 and minus x if x is less than 0. For example, if we have the absolute value of minus 4.12, it would become 4.12 as negative sign is cancelled with the negative sign. For the absolute value of 3, we would be left with 3 as our final answer. The last type of function in our today's lecture is parametric function. Now, what actually is parametric function? Sometimes the relation between x and y needs to be expressed in terms of a third variable, which is called a parameter. Hence the name parametric function. Such type of functions are called parametric functions. For example, we have the equation of parabola, that is x is equal to at square and y is equal to at. Now here we can see that x and y are represented in terms of a third parameter, that is t. Hence it is an example of the parametric function. Similarly, the equation of a circle, that is x is equal to a cos theta and y is equal to a sine theta are also example of parametric functions. Well, that's all from us in today's lecture.